Will a computer ever be able to write complex, accurate code? All the experts say that it's not possible. We're going to show you that it is indeed possible, and not only is it possible, but we've actually done it. We've attacked some of the hardest problems, including financial applications, Monte Carlo simulation, and databases. The key to it is an entirely new approach to how we specify the software. In this first of 3 videos, we will discuss the shortcomings of current methods. It's our contention that we've been going down the wrong path for the last 70 years, and that it's leading us to a dead end. We will point to a completely new approach that is based on visual, easy-to-use specifications. In the second video, we will demonstrate these visual specifications in detail and discuss the explosive implications. In the third video, you will see how the actuator analyzes these visual specifications and builds the software right in front of your eyes. By the end, you will see that the actuator overcomes every single one of the current shortcomings we outline here. It will transform how we develop software. Let's look at where we are. The demand for software is exploding, and we can't keep up. Many software applications are huge and complex. Software coding is hard, and it needs our brightest minds. Unfortunately, the quality of this software can leave a lot to be desired. It's error-prone, expensive, takes too long, and rarely does what it should. Let's take a closer look. If you look at the hardware that we run our software on, the future looks bright. There's no need to dwell too much on the enormous advances we've seen here. With 10-year-old hardware going for pennies on the dollar, it's no longer a limiting factor. Systems infrastructure has also advanced by leaps and bounds. A teenager in their pajamas can now afford access to all of this. If only software development had kept pace. But after 70 years, we still write software programs based on the same kind of algorithms described by Alan Turing. Precise sequences of low-level instructions that are built by hand, one line at a time. It seems quite natural since it mimics how the computer actually works. A software program might be built from a tangle of tens of thousands of these logical instructions, each one meticulously crafted and put in exactly the right place. Software specifications haven't changed much either. They tend to broadly follow the logical structure of a software program. So where's the problem? We'll first look at programming and then at specifications. Programming is fiendishly difficult and takes years to master. Very few people can do it well. Software projects take too long. There are always surprises, especially with new technology, and you seldom get it right the first time. The bigger the problem, the worse it gets, and throwing more bodies at it introduces new problems. It's easy to make mistakes, often dozens of them in the same day, and you can never be sure you've fixed every one. The cost of computer errors can be catastrophic. We've all seen airports and airlines shutting down due to software glitches. Even worse, the British Post Office scandal led to the wrongful conviction of 700 postmasters, with some even thrown in jail. Finally, software is hard to maintain. The original coders might be long gone, and there is no documentation. It's almost quicker to just rewrite it. How has coding advanced? Things like pair programming, formal code reviews, and Stack Overflow are nothing more than getting help from others. But in the end, you still have to write the code. Even with GitHub Copilot, you need to check it and then integrate its code snippets into your software. Integrated development environments help you organize your code, debug it, and use good syntax. But again, you still have to write it. Object-oriented programming is the only really big innovation. It allows you to break your code into reusable blocks. Unfortunately, it's extremely hard. Current AI models like ChatGPT are called large language models because they take written input and generate pictures and text. Can they ever be used to generate complex code? Experts say no, since they're prone to guesswork and hallucination. For generating source code, this can never be good enough. As we said before, computers need precise instructions. If you cannot describe exactly what you want, then you can't know what you will get back. As a result, you still need a skilled software engineer to carefully review the output and fix it. Perhaps Best we can hope for is the LLM providing suggestions for the human coder, who still has to do all of the work. Let's see what Mark Zuckerberg thinks. What kinds of thinking skills do the LLMs have? So far, not much. Here is a notorious 5 apples problem using ChatGPT. And in this example from Google's DeepMind, it took more text to specify the program than the program itself contains. And that's for a problem a 5-year-old could solve. It's hard to imagine using this to build a complex financial model. As you can see, none of these approaches help you figure out the logic. A human coder still has to do all of the work. And they certainly don't point the way towards computer writing its own code. It's not at all clear where they can go next. The root of the problem lies in how we create software specifications. You see, for a computer to write software, you need to tell it exactly what you want in precise detail. But we currently have no way to do that without also saying how to do it. This is because the pseudocode used in software specifications has to match the logical structure of the finished software. This quote from the brain trust at Intel and MIT says it best. In other words, to fully specify software, you practically have to write the software itself. There are 2 consequences to this. First, many low-level decisions are left for the programmer to address on the fly. These small decisions end up buried in the code. Second, the programmer and the customer don't always understand each other. As a result, the software isn't what the client asked for, or even what they actually needed, and it ends up being redone. This can lead to delays, with crucial features either absent or postponed. In extreme cases, the project will be cancelled or butchered beyond recognition. This is best summed up by the classic 1970s cartoon. It's clearly a mess. A lot of time is also spent on project management. It's already hard enough, but as we've seen, current approaches to coding and specifications make it 10 times worse. To quickly summarise our current predicament, we need more software, but it's hard to write, takes too long, doesn't do what you want, and is filled with errors. We're heading down a dead end and it's getting worse. People talk about large language models generating code, but tech experts know that they are not reliable and can never be reliable. So far, I haven't told you anything you didn't already know. So where do we go next? It would be nice if a computer could somehow automate all of this and create the software for us. But with current tools, that seems like a far-off pipe dream. In the next video, we're going to show you something completely different. We will show you visual software specifications that are built using special components called inverts. Inverts can be used by a layman since they require no understanding of computer logic. They are connected in a flexible but controlled way to fully specify software of almost unlimited variety. We have already created extensive libraries of inverts that cover some of the most complex models we know. You'll also see the guardrails that ensure that the actuator generates bulletproof code. By the end, you will see how she practically eliminates all of our current difficulties. We'll see you then.